Hello ROS developers, welcome to a new live class today from another special place. So not our usual place, but as you can see we have already organized, so it looks like a kind of corporative in there. And yeah, we are ready and we have a very exciting class today. It's about how to move two-arm robots at the same time, yeah, so you can do it at the same time if you want and if you program properly. But what we are going to do is to show you how you can launch those two arms in a single simulation, and then how to launch Moveit in order to control those two arms separately. So that's a lot of work to do, so we'll have to start now. And as always, as you know, so what we are going to do is to use a ROSject that I'm going to share with you. This ROSject will contain all the documentation, it contains some code that we have included and simulations, etc. So you are going to get all the material that I'm going to use in this live class that you can see here. Is in this direction. I don't know. No, on the other. Yeah, there is some delay here. So here, yeah. That's a stupid software of you know that they do kind of a mirror, and it looks very so that I get confused. So anyway. So I'm going to share with you that information, then you are going to open the same material using your web browser, and then you are going to practice with me at the same time. Yes, you are ready? Everything is ready, it's free, and it's very simple. So I'm going just to share a link of this code that it's containing what we call a ROSject. A ROSject is a ROS project. So I'm going to put this link there on the chat, then you can go click on the link, and then by clicking it's going to automatically create a copy for you and you will be set up. So don't worry, I'm going to show you the instructions, so you are going to follow with me, and it's very, very simple, step by step, so you don't get lost. And in case that you get lost, here we have the chat. So use the chat, ask me the questions, and I will try to answer the best as I can. So I want you to learn here in this live class, okay? So I want you to leave this class knowing more than you knew before you came. Then for that, in case that you get stuck, you get confused, question on the chat, and I'll be there to the rescue, okay guys? Okay, very good. So before we start, let me say hi to the people that is here on the chat. I can see Gimnet, he was the first one. Hello Gimnet, how you doing? Then the cool wizard, that he is there with a robotic icon also, hello. And then we have now Cashreto, who came the previous live class also, hello. And also here Gumpy6, hello ROS developers. Yes, that's the message. That's what we are, isn't it? We are ROS developers or becoming ROS developers. So people, if you are there on the chat and then you want to say hello, just go ahead and say it. If not, you are maybe shy or something, you are also welcome, but be sure to practice with me, okay? Just listening and watching is not going to make you a better ROS developer. So you need to practice, and we are ready for that. So I'm eager for you to do that. Okay? Okay, so let's go. Let me share with you my full screen, and then you can see how I'm going to share this ROSject that I have here. Here, this is the notebook with the instructions for today. And then I'm going to share that. Okay, so this is the whole ROSject that is called live class. Well, it's here. I cannot show you more. Okay, so it's here, the title, that's it. So let me go to my list of ROSjects. So if I click here on my list of ROSjects, then I have several things here, and this is a ROSject for today. I'm going to share with you. So remember that you can do that also with the ROSject that you have. So in case that you have created ROSject or this ROSject itself, you can share with other people. Just click in here, and then you get the link here. So get the link, and then by clicking, by sharing that link, anybody that gets that link is going to get access to the same code and documentation. So now I'm going to the chat that is here, and I'm going to share it with all the community there. Then hello, I can see that IKX1000 has arrived. Hello, how you doing? I think that this is the name of the next Terminator movie, maybe? I don't know. Very strange name. Just joking, just joking. So guys, do you have there the link? Click on the link and then you are going to get a copy of my ROSject. Then we are going to open it and start practicing, okay? So let me know if you have any problem. Click on there, then follow the process that says yes. And then here I see I have a comment here in the chat that is Benin observer that says can't hear anything. But here the rest of the people, they say they can hear. Maybe it's something misconfigured in your system. The cool wizard, he's saying is fine there. Thank you, the cool wizard, for confirming. And then the rest of the people, they are following the discussion. So please, Benin server, check your configuration. Maybe you have something wrong in your computer. Here we have hello 2410. Hi ROS developers. Yes, hi, how are you doing? So did you get the ROS yet? Let me paste it here again for you. I don't know, you just arrived. Then there is a ROS. It's the same, okay? Don't click twice on the same link because you are going to get copies of the same thing. Not necessary. And then click on there, okay? And let's go. I'm going to start unless somebody else says something that it has a problem or something. So just a few seconds more, waiting for any possible problem. And no, I can see that people is getting into the class, new people. So people, if you are just entering right now, go to the back of the class, but grab the ROSject and start practicing. And hello says that is Chris here. Everything looks great. Okay, Chris, great. That's more understandable, Chris, than hello 2410. Okay, so let's go. Guys, let's start. Then what do you have to do in order to open the ROSject? Click here on open and then press open the ROSject. So I have already opened in order to go faster. Okay, so mine is already open here. Then when you open, you are going to get this screen. I don't know if it is worth that I select it. So, but, well, let me do it, okay, just for the sake of understandable. Then in my case, so you are going to use the basic one. It is okay, but it's going to be today, it's going to be a little bit slow, you're working, okay, basic, because we have many robots there, I mean 2 robots, so maybe you are going to see that it goes slow, but it works perfectly, okay, with the basic configuration. Then in my case, I'm going to use the Pro one because it has 8 CPUs, so in order to show you better as a teacher, but I'm only using the Pro one in those series that we have been doing in the last month, where we are showing several robots, because otherwise it's very slow in my case, and then the whole class goes a lot slower. But you should be fine with basic, okay, for learning the concepts and understanding what is happening. So let me select the Pro one in my case. In your case, you should select the basic. And in case that you have bought some credits for Pro one, perfect, go ahead, go Pro one, and then you're going to move smoother. Let's go. Let's open the ROSject, and then when you open, then I'm going to close the previous one that I have open. Yeah, so let me close it. So this dialog is going to show you how it is initializing the machines, and then after a few seconds you should get the initial screen. In this case, I recommend you to ask no, because we are starting from 0. When you ask no, or either if you ask yes, then the first thing that opens automatically is the notebook here that contains the instructions that we are going to follow today. In case, let me repeat every day, every live class I repeat the same thing, but I don't want to get people to get lost in the class, so people have different times, you know, so I understand. Then in case that this gets closed like this, for whatever the reason, you close it, you hide it, whatever, you can rehab it by going to Tools. Get it back by going to Tools, then Jupyter Notebook. Select that. Then this is going to show you here the Jupyter notebook, and here there are a couple of them. Don't use this one because it's the default one. Let's use the one multi-robots exploration. Let's click on there. Okay, the name is also not correct. We didn't have time to change it, but that's okay. You understand us. I think that you can forgive us for those small mistakes. Great, so here we have, okay, so I presume that everybody is here on the same page. Let me have a quick look at the chat and see if everybody is there. The people that arrive later can scroll back in the chat, fake. Please find the ROSject here. Okay, yes, exactly. So sorry for the people that arrived back. We are going to find, for the next live class, we are going to figure out a way of having this solved because this is not acceptable. So people that arrive late must be able to scroll back. Okay, so Laria Mikel, by the way, your t-shirt is on its way. Okay, I promise. That is Laria Mikel. He is one of the people that came to the ROS Developers Conference that we organized in July this year. And he was the winner of one of the t-shirts of the ROS developer. I am a ROS developer, and I still own him this t-shirt. I mean, and then, but I received an email from him today, and I promise to send it today. Okay, great. Hey, yeah, so no problem. Okay, let's go, guys. Let's go on. Let's start to do the important thing. And wait a second. Still, Benin observer still can get the audio. I'm so sorry, Benin. I cannot do anything from here. Yeah, because everybody is reporting. It's something on your side. Then, okay, you can hear me. So I'm explaining you. But let me tell you that you should see then the recorded version. Okay, we are publishing this on this channel and also in YouTube. So just watch the recorded version. You get the ROSject now, and that's all. So get, let me say here, how can I, Benin observer, yes, like this, get the ROSject now, and then watch later. Benin, watch the recorded session later. Okay, sorry, I cannot do anything else. I'm sorry. So let's go guys. Then why is this class? So this class is very important because we are working along the last month on how to control several robots for different purposes, and we have been using the fleet of robots that move around. In this case, we are concentrating on armed robots, several armed robots, and that's interesting. For example, for a robot that have two arms and they have to cooperate. That's very interesting. Also, in case that you have a lot of industrial robots in a chain and you want to control them. So that will be the case. And this ROSject has been created by Christian, who is one of the interns at the construct, by Alberto, who is one of the members of the construct, and myself. And the idea started from Murtaza Basu. So Murtaza is a ROS developer that was having some problems in controlling a couple of Universal Robot 5 robots by using a couple of them on the same simulation by using different Moveit instances. Then he sent us the question, and he also created a ROSject showing the simulation and had some problems. Then we decided that was very, very interesting subject, and then we just took it. It took us a little while to answer his question, but here we are answering the question. We thought that could be very interesting for the rest of the people, the rest of the community, and here it is. So thank you, Murtaza Basu, for sending us your question and trusting us for helping you in that problem. And let's go. Let's see to everyone. What do we need in order to understand the class of today? So we need to understand a little bit of ROS, okay? So it's not starting from zero. It's not basic class. So you need to understand basic knowledge of ROS. In case that you don't, here there is a course, an online course on the notebook. And also you need to understand a little bit how Moveit works, at least how to configure and launch a couple of things. Just basic Moveit configuration for industrial robots. In case that you don't, there is another course there, an online course that you can take. Okay, but don't worry. If you don't worry. Stay with me, and we are going to go step by step. Okay, and what we are going to do is the following things. First, we are going to learn how to launch 2 Universal Robot 5 robots in the same simulation. Then we are going to configure Moveit for a Universal Robot type of arm. So we are going to create the configuration file of Moveit for a robot of this kind. And then third, we are going to launch 2 different Moveit instances based on that configuration, 1 per each Universal Robot. And then you are going to be able to move them separately. So provide 2 goals, 1 per each arm. So that's it. Let's go. That's the path of the ROS developer. So let's go. So for the simulation, it's going to be something like this, like you can see here. And we are going to start from scratch. I mean, today we are going to start by downloading the official simulation. Well, the simulation provided by ROS Industrial of the Universal Robot 5. So let's start. Before we start, let me check the chat to see if something is there. Okay, and then observer, check your audio settings, says Gompi, and then Benin observer says I can hear you. That's super great. So very happy that you are with us now. And thank you, Gompi6, for your help on that, supporting all the others' attendance to the live class. Okay, let's go. So the first thing that we need to do is to launch a shell. So go to Tools, to Menu Tools, then select Shell, and this new window is going to appear. As you can see, my speed is a lot faster than in opening and launching here because of the 8 CPUs, and you can see my CPU average is lower. That's because I'm using the 8. In your case, working the same thing, maybe a little bit slower if you are using the basic configuration that has 2 CPUs. But don't worry, okay? So we go step by step. No hurries here. Then, here you have information about the Universal Robots using in ROS in that link. So I'm going to go straight into the place where we are going to clone the simulation from the ROS Industrial repo. The ROS Industrial, remember, is this branch, let's say, of ROS that is dedicated to apply ROS into industrial robots. It's a consortium, actually. And they have, I don't know if they have created it. I think the simulation or they are maintaining, I don't know exactly about the Universal Robot simulation. But the thing is that they have that in their repo, and we are going to use that as the official simulation for Universal Robot 5. So because we are going to clone a simulation, we have to store it into the ROSject, into the simulations workspace. Remember that here we have several workspaces created for us: the artificial intelligence workspace, CAD/CAM workspace, datasets, notebooks, and simulations. Each one is meant to contain different things. It's a ROSject, so it's a compendium of different parts. Now we are working with the simulation now, so let's go to the simulations workspace. So CD simulation workspace, and then we are going to put the simulation into the source directory. So you have to get into that one also. So go to simulations workspace / source. Now here is where we can clone the simulation, and let's do it. Here in the notebook, you can see the command is git clone and then the address. So that's the address of the official. You can copy the command and paste it here, and the clone is going to start proceeding, and then very quickly is done. Okay, so now, for example, if we go, you can do an ls here, and you will see that the Universal Robot has been created. But also, if we open the IDE, it's more interesting because it's going to show us all the file structure. So for opening the IDE, go to Tools again and select the IDE here. Great. We have this structure of all the workspaces I mentioned before. If you click on the simulations, then it's going to show us the build, the devel, the source, typical of a ROS workspace. Then click on the source, we are going to see the universal robot, and then click on there, and there are all the files about the simulation and some things more. Okay, so more things than only the simulation, but it's okay for the purpose of today. It's okay, we don't have to do a cleanup in here. Let me check the chat if there is any question. No, people, you are following. Okay, so you have cloned this simulation with me and you have it in the proper workspace. Very important, otherwise it's not going to work. Okay, let's continue. What does it says, the notebook? The notebook, we have the instructions. Okay, so the first thing is that we have to modify a little bit the provided simulation in order to allow us to launch several arms of the UR5. So how does it apply to other simulations of other robots? We don't know. We don't know, because maybe the simulations, they are badly prepared in other cases. Maybe the errors in other simulations are others. And in this specific case for the UR5, because what's the name of the guy? Murtaza, because Murtaza problem was with the UR5, so we have concentrated on solving this one. But in other ARM simulations, the problems for launching several arms in the same simulation could be different. It depends on how the simulation has been done. And this one has been quite nicely done. Just a small thing that we need to check and change. Okay, so what do we have to change? So we need to go to the UR gazebo folder package and then check this file that is called controller utils.launch. Okay, then we have this content here, and the thing that we have to do is to remove this line. We have to remove this line there, because this is the one that is prohibiting us from specifying a prefix for each universal robot arm. Okay, so that's setting the value to empty, and then it doesn't allow us to set it to other values. So let's remove that. Okay, so how do we do? Let's go to the IDE again, Tools, IDE. Then let me put it bigger here so you can see better. The thing is, I cannot increase the type here, but I hope that you can see properly. We are transmitting in the highest quality, so I hope you can see it well. Then go to the UR gazebo. UR gazebo is inside, let me see, UR universal robot. Remember, it's here or here. No, not there. Then here, sorry, it's here. UR gazebo, here it is. Then check inside the launch file, then we have the controllers utils. Okay, so open that one, and this is the line that I am mentioning. Okay, so that line you can just, is line number 7, so you can just delete it. Okay, because it's setting, that line is setting the TF prefix to empty for any case. Is always setting that to empty when we launch the UR5 simulation, and then we need to set this value to different values, one to robot 1 and another one to robot 2. So we need two different values on the TF prefix depending on which robot we are talking about. But that setting was preventing us, and that was the main problem with the simulation. I mean, it's the main one, because as you can see, let me check if I forget something else. The only thing is that, and then also we have added a couple of modifications, so we can specify the initial pose of each one of the robots when we launch it, and also the robot name. Because as you know, in Gazebo, every model has to have a robot name. So we cannot launch one robot saying UR5 and the other one UR5, then Gazebo collides and says, no, this already exists. So that's the other thing that we are going to modify. Okay, first one, we remove the TF prefix, setting to empty. Okay, so that's the original version of the file that is called the controllers utils.launch. This is the result, what we have to have. That's what we have done here. Just remove the line number 7. Okay, that's it. And then now we have to go to the UR5 launch file and then modify it also. So let me go here. We have some problem with overlapping, but it's okay. So let's go here to UR5 launch, open it, and then what we are doing, let me show you what here is when the UR5 is being launched. So let me show you what we are doing here. Just we are removing the launch of the empty wall. Okay, we are removing this from here because it doesn't correspond to the UR5 launch. The UR5 launch should be the one that launches the robot in an existing wall. Okay, well, that's how we organize. I mean, the original creators, they organize in a different way, that's okay. But in this case, for specific robots, it's better to organize in this way, to have a spawning of the robot in an existing wall. So we can call this spawning with different robot names. Then we can keep launching with different names until we have 1,000 robots there, and then the computer explodes, yes. But yeah, but theoretically that's possible. If we have the simulated wall in each one, then it doesn't work because every spawning of the UR5 will launch a new wall. Okay, that's why we have to remove it. So we have removed this, and then we also have removed the post option that says, hey, start the simulation in a post situation. So we remove that, and also the one that says start the GZ client, okay, as per default. Okay, so we are removing also that. Why? Because we are using here the ROS Development Studio, and then we don't need it because it's going to appear here as a gazebo window automatically. In case that you are launching this in your local machine, then you need this, or maybe launch the GZ client afterwards. So for now, we are removing this. Then also we are providing two arguments to this launch file. One is the robot name. What I mentioned is in order to allow to spawn a different launch, I spawn a UR5 with a specific name. So we can use the same launch for different instances of the same robot. And then an init pose, of course, because if we don't specify an init pose, then all these instances will be spawned at the same location, and they will collide, and then will be a mess in there. Okay, so that's it. Then afterwards, because we have those two parameters, then we are using it where we spawn the robot that is here in this line here. Yes, exactly. You see here the model is taking the robot name, and the location it's here. Okay, the init pose. Okay, so in order to not to do a mistake, what we are going to do is to copy all this and then replace this UR5 launch. You can later, if you want, you can compare one and the other, but I recommend you to do like this because otherwise some error can happen. So just select everything here in the notebook, okay, the one that says UR5 launch, copy, okay, copy it, copy, then come here to your UR5 launch file, select again everything, and then paste. Well, you can delete and then paste. Okay, I'm going step by step, different types of audience we have. So, okay, so we have substitute the original one by this one, but the only things that we have done is what I explained to you. Very, very simple. Now, that's what we are going to do is to create another launch file that is going to call that UR5 launch twice. So it's going to call it then with one name, and then a second time with another name and a different init position, and so on, so on. So we'll have two different armed robots using the same launch file. And for that, let's create a package, another package that we are going to call 2arms. So here is the command. So we need to use the terminal, the one that we opened before, and go inside the simulation workspace /source that we are already there, and then do the command catkin create package 2arms 2_arms space ROSpy. It depends on ROSpy, just in case that we need to create some Python programs in there. Actually, we are going to create only a launch file, but it's okay. So create package, and that's it. Create it. Okay, so now we have this second package in there. And there we are going to create inside the package. Let me use the IDE, and I have a problem here with the on top. So let me use the IDE and close this universal robot. Here it is my package 2 arms. So I'm going to open it, and there is no launch directory. So I'm going to select the 2 arms and then do a right click, new folder, and I'm going to create a launch folder. Okay, so launch folder. Now inside the 2 arms we have the source and the launch. Inside the launch, I'm going to do again a right click on the launch directory and select new file. Here is where we are going to create this file, this launch file, that is going to be called start.launch. And then we have it here open already, empty in empty. So what is the content of this? The content is just that one that is here. That what it does is basically is to launch the empty world that we needed. So we need an empty world where to put the robot. Then we have the calling of the UR5 launch file with TF prefix for this robot 1, the init pose with this position, and the robot name with this name. So those are the variables that we need to set for one robot. So then we repeat to the second one with the proper different names, different locations, and different TF prefix. And then we put everything in there inside a group for one specific robot. What this ensures us is that the topics of this UR5, the robot 1, will not collide with the topics of the second one. The TF prefix is for ensuring that the TF frames, they do not collide, so they do not get mixed. You know, the frames of one robot belong to that robot and the frames to the other belong to the other. Okay, so I think it's quite simple. Then we have some the arguments that can be passed in order to improve this. So when you call it, but we actually don't need it. We are going to use just the default values ones, and that's it. So then select this code here of the launch file, copy it, and then paste it here. And there it is. Now I think it's time that we launch it. So in order to launch it, let's go to the simulations menu here on the top and then choose launch file, because we are going to launch a simulation from our workspace, the home user simulation workspace. Okay, so select here, choose launch file, and here on the menu that appears here on the pop-up, select on the menu, on lateral menu, the start.launch. So that's the file that is going to launch our 2 robots. So go to launch, press launch, and then a new window is going to appear and the robots should appear there. In the meantime that this is running, let me check if there is any question on the chat. Okay, no questions. No questions. Let me know if you are following, if you are having any trouble. Here my simulation, as you can see, has already opened very quickly, and it's here I have the 2 arm robots there. Okay, so these are the 2 ones, and at present they don't do much because they are just there staying waiting for us. Okay, so that's it. So now we are going to see how to configure this with Moveit and make it move. That's what we want. We don't have time because it's a short live class, but we could, for example, check the topics of those robots. We could also plot the TF of the whole system, and you will see that there are 2 branches, one robot and the other one, and they are not mixed. So I it's my exercise for you to that you identify all those things and you practice by yourself in order to understand. Then Benin Observer says, is all this available as a ROSject after this class is over? Yes, I mean the ROSject that you have is are there forever for you, so you can keep it. The problem is that the link, so the link is going to stay there for one day like this, more or less, just for people who cannot attend the class and they watch it later along the day. But then after that, this link is going to die, so it's not going to work if you press on the link. But the ROSject that you have is for you forever. And then there is the cool wizard that says, are the PID errors normal? So which PID errors? Let me check. Yeah, so if there is, oh, okay, so those ones, yes, these are normal. It's because we haven't said it. We haven't said it, and just, so this is normal because it's taking the default values, and we didn't pay attention to that. So you can go and try to provide those values and to configure properly in order to do it better, you know, this demonstration. But it's going to work now with the default value, so it's going to work. Sometimes, you know, because preparing this takes so much time that we don't have time to solve all these little things. So as much as the point of the live class is shown, that's what we concentrate, because we don't have the time, really. Well, if you are ROS developers, you understand how much time does it takes to do just the simplest thing in ROS is very complex, so it takes a lot of time. Well, anyway, so let's prepare the Moveit package, okay? So for that, let's launch the Moveit package and then start providing all the information related to the UR5. Then in order to launch it, here you have the launch command. This is the typical for Moveit, okay, to launch the setup assistant. So for this we need the shell. So let me open the shell and then launch the command. And the command is going to launch what I mentioned, is the Moveit setup assistant. Is the one that allows you to configure Moveit for a specific robot based on its URDF description. So that's what we are going to do. You are going to see it's very, very simple. That's an amazing job that they have done. The people from Moveit, they are great. So I can remember when I was trying to control robot arms without this, when Moveit didn't exist, and it was horrible life. It was a horrible life, very difficult. Okay, so you have the command there. You launch it, and then the Moveit setup assistant should have opened. And where does it open? Well, this is a graphical window, it's extra window that is not a web window. So in order to do that, to visualize these kind of applications in the web browser, you need to go to the tools menu and select the graphical tools. This graphical tool is a window for you to get all the other application windows that Linux or ROS or whatever they are creating. Okay, so they are going to appear all there. So if you get the message, press on load graphical tools and it's going to show here. And let me make it a little bit larger. And yeah, I don't know why this looks like that, but if you put it in larger, so enlarge this to the whole scene, then it's going to show properly. And actually I'm going to do one thing. I'm going to detach this window here and I'm going to put it as a new tab here. How do I do? By clicking on this icon here. If you click here, then it's going to generate a new tab. You see, so here in the main space we have this cleaner and we have better space for working, and here for the graphical tools. Okay, first thing we need to do is to create a new Moveit configuration package. Select that option, okay, that click. And now we are going to load the URDF as I mentioned before. For that, click on Browse and then go to the user directory. We are going to look for the URDF files, okay? The path is on the notebook So in case of emergency, we can look there. Let me check if I can find it myself. It's an user, then simulation workspace, source, universal robot, then UR gazebo. No, sorry, UR description. It was UR description, URDF, and here UR5 robot URDF chakro. This one. No, sorry, UR5 URDF chakro. Okay, I'm not sure. Let me check. If which one was? Is the robot one? Is the robot one? Okay, yeah. So yeah, so you have to know this. So because if you don't know, then you have to go to the file, check what is inside, and then, oh, that's not the one. Then, or the documentation of the simulation must tell you. That's the only. So we have done it before, and then we know that is this. That's why we wrote on the notebook. So UR5 robot URDF chakra, select that one, and then open. And then click here on the icon below load files. Great, so it looks like it has loaded the model here. You have here a 3D simulation of what has loaded. Great, so we have it and it looks correct, yes? Now, we have to go to the self collisions option here on the left hand side menu that we have on the Moveit setup assistant, self collisions. Press that icon and in the new screen that appears, press the button generate collision matrix. Then it's going to generate a matrix that is detecting which parts belong to itself. Now, let's go to virtual joins. And here, let's add a new virtual join, because the virtual join is the one that is going to attach the base of the robot to the wall. Otherwise, if we don't do that, then the robot can move around and then start jumping around the place. Because this robot, in the simulation that we have, the robot is not here in the simulation. The robots are not attached to a table or to an arm or to something. So that's why we need this virtual joint. So on virtual joins, click on add virtual join, and then let me copy the values that we have on the notebook. Okay, these are the ones we have found. We want for this example. Okay, later you can modify and use the other ones if you want, according to your necessities. But for now, in order to work with the system that we have prepared, it's better if we can set that. So the virtual join name we are going to call as fixed base with capitals. So camel case it's called. And then the child link is going to be walled, and the parent frame also walled. And it's a type fixed. So it was fixed base. So type here fixed base. Then the child link is wall, and the parent frame name is also wall. And then join type fixed is going to be attached there and cannot be moved. So press save. Okay, we have one virtual join. Then planning groups. Let's create another group. So let's add a group. These planning groups, they allow us to planify the whole set of joins for a complete movement as a group. Okay, so then for the group name, let's copy also the values that we have here on the menu. It's manipulator. Okay, that's a label for the group, manipulator, could be whatever. Then the kinematic solver, we are going to use here, if you select here, the KDL. Why this one? Why another one? I don't know. This is the one that I have been using with Moveit since I started, and for me it works. I didn't have the time to look at the others, and so I don't know what are the advantages. In case that you know and you would like to share with us, we'll be super happy to hear from you. And then the default planner group, here you have to select which one was RRT. Yeah. Let me see. It's on the here. Default is yes. Here it says none, but I think that we should select the RRT, but I'm not sure now. Okay, let's leave as RRT, and then we'll continue and see if something goes wrong. So then next thing is to, let me see, it's to yeah, so now we have to define the kinematic chain that this group is going to contain. So it means all the elements that they are going to contain. For that, we need to select here on this button that is very cryptic, that says add kinematic chain. So click on there and then expand everything. Then here you are going to select the base link. It means the base of the kinematic chain, and the tip link, the final one that we are going to use as a link. Then for that, very simple way is to go to the one that we want as a base. Is going to be the base link, of course, and then you select that and then press here the button, choose the one selected for the base link, and then for the tip link select the tool and then choose selected. Okay, then press save. So we have created this group planning that it's going to allow Moveit to plan this complete set of joints for performing a movement in conjunction, all of them. Okay, so robot poses. Let's define just a very simple robot pose so we can test that the robot is able to move to that one. And for that, a robot pose is a position that we would like to have in the robot. So go to add pose, and this is just an example. Okay, so I'm going to select, to move just kind of randomly, not down, let's put it up, yes, and then here like this, and so you can select the pose as you want, and then the system will try to do it. Okay, that one we cannot see, but it's okay. And pose name, you have to provide a name, so let's test pose 1, for example. Planning group is the group that we want to move. As you can see, we only have one group, so that's why. Then you save. And basically that's it, because we don't have anything else. Then the only thing that we are going to do is to add the author information. You have to put your name here. So I'm going to put mine and an email. So this is mandatory for being possible to save the configuration files. Then once you have included your name and your email, go to the configuration files, and then we are going to generate the package. But before that, we are going to put this package into the specific directory. So go to browse. Then this package is going to control the robot. So this is software that should be running on the real robot, not on the simulation. Because of that, and now it's going to affect the simulation. Yes, it's going to control the simulation, but in case that we have the real robot, this code would control the real robot. Because of that, the code that we are going to generate with Moveit must go to the Catkin workspace. Okay, so let's go to that. Is you press user, then Catkin workspace, then source, and here we have a Moveit RBase configuration that we have created for you. Is already there. And here then we need another directory that I don't remember how we call it. Let me check it here. And we call it demo underscore Moveit underscore config. Okay, so demo underscore Moveit underscore config. So we create that one here. We choose, and then it should appear here. Home user Catkin workspace source demo Moveit config. Okay, so now that we are happy with that, then press generate package, and then it's going to, yeah, it says that we haven't defined any end effector because we don't have now in the robot, so it's okay. So say okay, and then generate package generated. Okay, so now you can exit the setup assistant, and done. We have configured the Moveit for one single robot. Okay, so now we are ready to modify this a little bit in order to launch for several robots, for as many robots as you want. Let me go to the chat just a second, see if everything is working. Then we have here in Then that cool wizard says, okay, is the simulation required during the Moveit setup? And then Gumpy says, no, it's not. Yes, that's right. You don't need it. We just wanted to launch it to make more practice and have more fun in this live class. Okay, and see that, oh, we are progressing. We have 2 simulations there. So that's it. That's the purpose. And then he says that cool wizard much faster now that you closed, I presume. And that is right. I didn't think about that. I was thinking about making the class more fun, but it's true. If you close the simulation, then the Moveit system will go faster. That's right. Good point there. I didn't think about that. Great. Let's continue, guys, because just 10 minutes to finish. So let's go. Then what we are going to do is to modify a package with the controller file. Well, we are going to add, okay? We are going to add some files and modify a little bit. So in order to use the controllers that we want for our joints. So for that, let me open the IDE again. That is around here. And let me put it like this. I can see and move faster. Then in the config file, let's go to the Catkin workspace where our Moveit package is included. Catkin workspace, source, then demo Moveit config, the package that we have just created. And then inside there is a config directory. Then there, select that one, right click, new file. And then call it controllers.yaml. So that's the name of this new file that is going to contain our definition of the controllers, okay? And then you should copy this list of controllers. Basically, it's just defining the controllers, the names of the joints and the type of controller that we are going to use on those joints. Basically, it's just that. I recommend you to watch our series of live classes about the controllers and how to use them, how to create your own ones, etc. So copy paste that here, and that's it. So that's it. So we are ready, and also we are specifying the action namespace for the Moveit action server that we are going to use for controlling the robot. Then we need to create another file here. In the, let me put it like this. We need to create another file here that contains the joint names. So we know those joints here as in the controller, but before that, the system must know which are the joint names to expect. For that, go to config, right click, new file, and create a file name that is called joint_names.yam. And in this file we are going to set just the controller joint names and then a sequence of which ones are there. That's the file. So that's the content of the file. It's just a line because this is what we got right here. So let me copy and paste it here on the file, and it's just a list containing all the joints that we are going to control. That's it. As simple as that. Now, finally, we are going to modify the default one, controller manager generated by the Moveit, in order to make use of those two files that we have created, the controllers and the joint names. And for that, you have to go and look for, in the launch folder, we are going to modify that launch file, okay? This is the one that is loading the controller's configuration and so on. So for that, inside the demo config, Moveit config directory here, package, close the config to avoid confusion, and then go to the launch, and here look for the UR5 Moveit controller manager. UR5 Moveit controller manager. You can open it, and then just replace. Okay, we are replacing the default one by the one that we have created. So let me remove all that and then copy the content here that contains our own definitions. So yeah, so basically we are doing just that, just loading our controllers YAM, and then we are not going to use the controller manager. Instead of that, we are going to load this Moveit controller manager. We are going to specify this one specifically. Okay, so we have that everything configured, and then we still need to modify another file more, and that's the only thing that remains in order to launch. Okay, so this is the file that is going to create the launching of the two Moveit instances, each one for each robot and with the proper configuration for each one. So it's going to launch the joint state publisher, the Moveit ROS window that is required for each one of the robots. So we are going to have two Moveit windows, one in each, controlling each of the robots. So let's go on, let's create that on the launch directory here on the demo Moveit config. Okay, so here select again this directory, right click, new file, and call it like it's indicated there, demo underscore planning underscore execution dot launch. And now let's add this launch file. The content of the launch file, you can see it here, and let me move that like this. And okay, let's copy here because it's a little bit difficult to watch here the whole file with the whole content. So let's copy here and got it. Select the whole cell and then paste it here on the demo planning execution launch. And let me put it a little bit larger. And a little bit larger like this. Yeah. Okay, so what we are doing is just launching 2 times the joint states publisher, the move group, and the RBase configuration for Moveit for each one of the robots. Basically, that's what we are doing. And we are encapsulating every one of those inside a group, okay, into a namespace. We could have created a single one with parameters and then relaunch based on 2 parameters, but we didn't have time, so we just copy paste. Okay, so that's the way of launching. So if you remove the groups, the group part, and then in case that you will have one single robot, that will be the way to launch the Moveit for that specific robot. But here what we are doing is just launching the whole thing that is required in order to have the control with Moveit and encapsulating it inside a group for each one of the robots. This is for robot 1, and then we repeat the same process for the robot 2. And then yeah, that's it. So we have that in ready, and then it's time that we launch it and see if we can control the robots. So for that, let's go to the terminal and launch this launch file that we have created. For that, ROS launch, the typical command, it's called demo Moveit config, demo Moveit config, and then it's called the demo planning execution. Demo planning execution. Okay, demo planning execution. Here it is. Okay, there we go. Then we launch it, and what it's going to do is to launch Moveit for the 2 robots. So if we go to the graphical tools window that we have here, we should see now, okay, so here is opening, okay, so we should see that we have 2 RBase configured windows with Moveit in the inside, each one for one of the robots. You can see here for robot 1 and here for robot 2. Okay, both of them are the same. So if you select one of the windows, you are going to control one robot. This one for robot 1 and this one for robot 2. Then the only thing that before you start sending goals to this is to add to the scene an object in order to prevent the robot to try to go through the ground in the movements, because the robot doesn't know that it's attached to the ground. It doesn't. Then it doesn't identify that as an object that he cannot move through. So if you start planning now, the robot is going to collide against the ground and then crash, and the simulation is going to crash completely. So for that, we have included now a method to add a ground into each one of the robots. It's very simple. You go to the scenes object here. For example, this is robot 2, okay? You can do it with any of those. Scene objects, and then here, import from text. So you click on there, and then we have included, if you go to user, King workspace, then source, we have included here a box scene. This is a file that specifies like a small box beneath the robot. It's a small box that is kind of indicating that there is an object there beneath the robot. So if you select that one and then open, you're going to see that it appears here in the 3D. So now it is safe to start planning the robot and prevent it colliding from the ground. So how do we do? First, go to planning here, and then select goal state. Let's select our test pose, and then update. If you update, then that's my selected pose. This is the current location, and this is the selected pose. So now if I do a plan, then it's going to find a plan to reach that point. Okay, so this is just planning. So it's thinking in the mind of the robot, oh, I can do it like this, I can do it like this. Okay, now if I execute, then the actual robot, in this case in the simulation, is going to be doing that movement. Okay, so I was too late, so it already did it. Okay, so here we have one. Then we can move faster. For example, let's select another pose, a random valid one, then update. So you see there is a second position, and then plan and execute. And then you go here, and there you can see it moving. Oh, okay, so that's a strange. Okay, should have detected. So I don't understand why. Okay, let me see, scenes objects. Okay, so it has collided against that. Let me see, current. Select the current. Let me see which one is this. Well, okay, so that's broken already. Yeah, when that happens, then it's broken, and then nothing happens. So that's what we prevented with the ground, because when we were preparing this live class, the robot was always finding solutions through the ground, and then we included this scene in order to prevent that robot, and then it was working. I don't understand why it didn't take that into account. Okay, so I don't know. Let me select for the other one. Let's do the same for the number one. So go to the select objects, then import from text, and go and select this in the King workspace, source, boxes, scene. Then we have it there. Now planning, let me select a random one. So it's there. Let me select the plan. Let me see the plan. How is it? Okay, it's not planning. It's not getting that one. Let me select another one. Okay, those are very, very difficult ones. Okay, let me see if this one is not touching. You must select an option that doesn't collide against the green thing, okay, because it's a final position. So when the goal state is the goal state is against the green one, then you are not going to get, so it's going to collide for sure. I mean, nobody should detect. Now this final position is colliding against the green one, so it's not valid. This one also, this one also, this one also, that's colliding against many things. Here also. Okay, so let me select my test pose one and update. So that's my test pose. Then let me plan. Okay, yeah, that's correct. That's correct. So it's possible to reach that point. So let me execute for the number 1 and then go back and go to the movement. Okay, so that's one is working now. Then let me select another pose, a random one. Okay, that one is not possible. Another one, another one, another one. Okay, that one is a random one. So let's see if that can plan without colliding with the bottom. Okay, no, it's doing it. So it's colliding. You can see the plan, how it goes there. But I don't understand that. Okay, so I will have to think and check what is happening in there. Why is not taking into account the scene object that we have imported. Okay. Okay, so yeah, so I have to check about that and see why is not taking that into account. So sorry for that, but well, the main point that I wanted to share here with you is that how to modify this simulation in order to launch several UR5, and then how to launch the Moveit configuration for different robots so they don't collide neither. So now with this configuration of Moveit, now you can start creating your own programs that attack the different move groups for each one of the robots. So you can create your own ROS programs that are those programs that are controlling the robots in different ways. So I'm coordinating maybe them between them, doing a collaboration. If it is in a single robot, then you can attack one move group and the other move group at the same time, and then make them like kind of grasp things at the same time, something like that. Okay, so let me see if there is something else that I'm missing here on the Jupyter notebook. So this is about the final, and then mission complete. Yes, so that's it. Just wanted to tell you that what we are teaching here, it's part of the content that we are having in a larger extent at the Robotic Ignite Academy. So here we are attaching very specific subject, but we have created an online academy that is called the Robot Ignite Academy that contains many courses online following this procedure with a notebook, with a simulation, so you can see all the time at any moment in time how you are progressing, how to execute your program and see the result on the simulation. And you only need a web browser. It's also very convenient for universities or schools or even companies that they want to make a training of their people, you know. And that is all from my side. Let me check if there is another question there on the chat that I can answer before we close for today. And here we have some questions here. People have been talking very good. Okay, so let me go back here to a little bit. Hello, Marcus says, Marcus Bucol. Hello, Marcus. Nice that you joined, even if late. Can somebody share the link? Yes, somebody did it. Thank you, hello. Ricardo, that is missing an S in the file join names. Okay, joint names. Okay, thanks, but it seems that it does not work, Marcus says. Okay. Then Marcus has. So you say that it's joint names. Let me see. But it is working anyway. So it's strange that. Let me see how. No, it's joint names. You can see it's loading the file here. Joint names. So maybe in the notebook is wrong. Oh yes, in the notebook is wrong. And so in the notebook is wrong because here is. As you can see, is loading the join names file, is loading, and then it has to be join names. Yeah, and then how did I do it? So did I wrote correctly? Okay, so I don't know. Join names, yes, I did it like that. Maybe it's because my memory that just unconsciously just wrote like that. But yeah, the name is joint names. So let me change here the notebook so people doesn't confuse. Anyway, thank you for letting me know. Okay, thank you. Hello, thank you very much. Then we have Benin Observer says, later when accessing the ROSject, how do I download the code? Okay, in order to download the code, in case that you want, that I don't recommend, is you go here to the world file, here, and then here you have a button to download the whole thing. You have the whole button. Also, if you only want to download just a single part, you can come here to this, to the file. For example, let's say that you want to download just this directory, then you right click and then select download. Okay, and then you will have in your local computer. Or this one will download the whole ROSject, everything, the Jupyter notebook, etc., etc. But the thing is that I really don't understand why you want to have it in your local computer here, because here you can have it and share it and compare and modify. You can use any computer here. You don't need to have installed. This is something I was discussing yesterday. I was at the University of Luxembourg providing a live class, and then the teacher there, he said that about thinking about buying a Mac, but he was considering not to buy because he needed to use ROS. And then I said, well, but you can use the ROS Development Studio, the free account. It's more than enough for most of the people, and then you don't have to care about ROS installing your computer or going to another place and then you have all your ROSjects there, or sharing this with other people so the other people can make it work. If you get into your local computer, you always have this problem. Yes, the thing that they usually say is about the internet connection, but I mean, it is required, you know, the internet connection, but I mean, who doesn't have internet connections those days when working? Well, it's an option, okay? So just wanted to make you consider if it is really worth it, because in my case, I am working with a Mac and doing this live class with a Mac and creating those projects with a Mac. You can do it with a Windows machine. It's very, very convenient. Don't want to tell you more about that. It's your decision. So let me say, Hello says, sorry, in the demo planning said without DS. Okay, so Hello already found it. You can right click and select download also. Great, Hello, thank you. Gianfranco says, where I found the link to the ROSject, somebody did it. When you have all the ROSject in the left side open, download, okay, great, thank you, welcome. Unable to import scene, never mind, wrong button. Okay, Dave, how do I find courses on humanoid robots? We don't have about humanoid robots. We have about, the most humanoid that we have is about Thiago robot, for example, that we have a complete course about that. It's Thiago robot is from a company called Robotics, and it's has a torso, a camera, and then an arm, and it's moving by wheel. So it's actually a mobile manipulator. But about humanoid robots, no. Then SPK says, can I check previous ROSjects? I wanted to learn more about multiple robots creating a map. Great, so all the ROSjects for that, they are included into the Robot Ignite Academy. If you go there, then you can download all of them, watch the videos again, etc., etc. Let me put here the link, robotigniteacademy.com. This is our academy online. And that's it. Then how do I find the Thiago courses? The Thiago courses on the Robot Ignite Academy also. Yes, so those courses, of course, they do have some price, and so it's the way that you can support our work. As you can see, we are doing a lot of work for free, providing you with those simulations, with the documentation, all the code that we have prepared. You know, that's a lot of work, and we do it happily. So we are happy to do that because we love it. We love it to create those courses, to find the errors, and then come here excited to explain to you all this and make you learn. You know, we are happy. But at some point in time, we have to recover a little bit of money so we can pay our, for example, my caps. You see my super nice caps that I have, my t-shirt, and the rest of the team the same. So all the team is wearing a cap and a t-shirt, and no way, just joking. Just joking. Okay, so yeah, so that's where you can find at the Academy, and then it has a small cost. Just check it out and you will see how small it is. Then my teacher says, is there a chance to add helicopter to the simulation in the future? Yes, of course. Of course, actually, if we have, there exists the helicopter simulation, and then it's one chance. If I remember, we tried one, and it was a little bit quite complex simulation, if I remember properly, because it requires a lot of controllers. But let me think about it. Teacher, so can you suggest for what purpose would you need that? So maybe we can create a live class using that simulation and teaching some people to do something interesting with that simulation in that type of drone. By the way, it's a shame that this helicopter is discontinued, so you cannot buy anymore. Has been discontinued because the company has disappeared. It's a shame, but it is. So, my teacher, if you know, you can something you can suggest us either here or maybe a personal email or on the notes here on the video. We are going to upload right now the video to YouTube, so you can rewatch later, and you can put it on the comment. Okay, you say because you need to learn map ROS. Yes. Okay, that's a complex issue. Yes. Okay. So let me think. What can we do with this? Because that's a lot of work. Okay, that's a lot of work. Let me think. How can we structure that? Would be a very interesting subject also. So thank you very much for the suggestion, my teacher. So we are finishing here, guys. We have been here 1 hour 20 minutes almost. I mean, you need to go to your home, and I need to drink coffee. So thank you very much, guys. Then let me see you. Yeah, see you next week. We are going to start doing a series of ROS2 courses next week. So I hope that you are going to enjoy that. And then so it's going to allow you to start getting in touch with ROS2. Very interesting things. One final thing, Benin Observer saying that will be great if RIMC by Power Robotics will be a course too. Yes, that will be great. Let me show you just quickly that we have here in the projects that are here available on the ROSject. If you search for Tellez robot, just do a search, and then you can see here that we have the simulation of the Tellez robot. So you can get it. This is well, there are a lot of copies here. I don't know why. It should only appear the original one, but yeah, so this is a simulation of Tellez humanoid robot. Is a human-sized humanoid robot that the people from Power Robotics, they have created, and then they share with us. They share the controllers for the walking, so the people at the ROS development studio can use it. Okay, so this is a privilege thing that we have at the ROS development studio, that you have the controllers, because we have made an agreement with Power Robotics for that. They were so kind to let us use here, even if that's a feature for paying users, but anybody can use it. So if you launch it, then it's going to work for you. So for example, let's see that one. I don't know. Wait, I'm going to launch my own Tellez version, because I don't know if these people, they have modified. So let me search mine. Here it is, and then I'm going to launch it instead. Let me save first. Yeah, let me remind you, if you want to not to lose your changes, save the project, the ROSject here on the icon of the saving. So you press there and then save, yes, overwrite, and then it's going to save your changes, because otherwise they are going to be lost. I always forget to say that. Sorry. Okay, so I save it, then let me launch this one, and then you can see if I launch this robot in here. Did I select the second type? I don't know if I have selected. Moving too fast, then I don't know. Yeah, okay, here it is. Let me see. Oh yeah, I selected the Pro one. Great, so I'm going to have speed. Then here it says how you can select, how you can launch this gazebo. So you go to simulations, change the simulations, let's select the Tellez gazebo version 2. Okay, select that one. Let's see how it appears here. and then you can see here a humanoid robot. Yep, it's launching now, and let's see when it appears. In the meantime, let me see if you have any questions. So people is starting to leave. It's okay, you can leave, just finishing, because some people had some interest in this thing about the humanoid. So here we have the simulation of the Tellez humanoid robot. That's a human size. It's the latest robot by Power Robotics. That's an amazing piece of technology. And then you can get here the controllers up and running. So you have all the options, the options for making the robot walk, and also create some movements and different movements, and also walking. So let me see how was this is for the movement, launching the position controllers, and list of motions available, execute a motion, make it walk. So you have to stop the previous ones, and then let's launch these ones, the locomotion one. So let me launch very quickly. Okay, I'm moving quickly, I know, but hope you can follow me. Then here I'm going to launch the power locomotion walking controllers. So I have here this line, and there it goes. So now it's launching, and then we have here also a program for launching the GUI. Okay, wow. Okay, it appeared like like a double robot. It's kind of scary. This is a problem with the visualization. If this ever happened to you, there is only one robot, okay? Don't worry. Just refresh here the screen, and then only one should appear. Yeah. Okay, that's a problem in the visualization system. Okay, there it is, one robot. And now let's make it walk. So this is the, let me check that I'm not doing any mistake here. Is the Tellez, the start walking continuous? Okay, so we need another shell here, and let me launch those two. First this one. So in the ROSject you have the full instructions, okay? I'm not explaining how it goes, but just follow the instructions, and then you will get a better understanding. And then we launch it here, and there it is. Now this, what it does, it opens an RQT image that we can use it to command the robot. In order to see the RQT, let's go to graphical tools, and then it should appear here. And I'm not going to detach, I'm going to put it here, and click. Here it is. So now by using those two lines, we can make the robot turn, move forward, move backward, for example, moving like this. So now it should start moving. There it goes. Nice. And then you can include, for example, a certain part of turning. I mean, guys, this is a state of the art. This is the algorithm made by the people of Power Robotics, and as you can see, it's amazing. Yeah, I have seen the real robot, and it's also very impressive. It's my size almost, and well, you can see that it's turning to one side. Then we can try to make it move backwards, and also rotating. So moving backwards, rotating there. Well, you see, you have all the controllers there, and you can do a lot of things. So maybe you can create here a simulation of a home and make it appear there and work. Actually, I have an idea. Okay, let me cut all that. Let me Control-C. I know that, so you have to leave, you are free to leave. So let me do one experiment before I leave myself, because never done it before. So this is, I'm going to launch another environment and then spawn the robot on that environment. So let me see if I can Control C. So okay, the robot has fall down. Yeah, no problem. So let me see if I can spawn here first. Let me launch. I'm going to change the simulation. I'm going to select another world. So I'm going to select the world of the Japanese house that I love it. It's very cool. It's around here. Where is it? This that Japanese room without a robot. So I'm going to start an empty simulation with that. And then what I'm going to do is to launch the robot inside there. And for that is Tellez Gazebo version 2. Is I don't remember in which directory it is. Let me check here. IDE, let me see. Tellez description is the Tellez Gazebo. Here, Tellez version 2. Let me see if it has an empty wall or not. So it's launching an empty wall. Yes, so here is starting the wall, but I don't want this. I don't need it because I have launched this Japanese home that is loading. Okay, so it looks like there is a problem in here. Let me relaunch it again with I don't know. I'm just testing. Okay, so with a Husky robot, let me see if that works. But it looks like it's not finding the Japanese room. Okay, no, it's not finding it. So it's kind of not finding that. Okay, so let me check with a different environment, a simple one. Let's say donut warehouse. Start simulation. Let me see. Okay, so there is a problem because it's not possible. Just wanted to launch a different wall and then spawn the robot in there. Let me try this one. The one of the drones, the empty wall. No, it's a problem in the system. It's a problem. Okay, so sorry guys, we cannot have the robot working on one home and crashing against all the walls and so things. So I wanted just to check if it was nice to see that, but unfortunately it was not possible. Okay, so that's all for today, guys. So let's finish here. Thank you very much for coming here. I wait for you on the next live class. Okay, it's about ROS 2. And I don't remember now the title, but I will think about it and send you an email. If you are in our email list, you will receive a reminder of the live class. So thank you very much, guys. Everyone, see you around the world. Bye-bye. Oh, I forgot. Keep pushing your ROS learning, okay? Don't forget about that. Bye.